Well, welcome back inside Mission Control. You're now close up at the Public Affairs Console, and as I mentioned a few minutes ago, Laura Lucier, who is the robotics officer, is actually on console all day today. And of course, she's keenly interested in all of the activities associated with the robotic arm of the station, Canadarm2, but also, of course, the EVA that you just saw Ernie Bell describe as part of his press conference a week or so ago. So, Laura, thanks a lot for stepping off over there and coming over here and joining us. I appreciate it.
My pleasure, Kyle. It's always nice to have a little break.
Well, I was describing earlier, the robotics function is integral to just about every spacewalk. But you guys have a very big task associated with this flight, but it's no better to hear from the experts. So, and of course, you've been here. You sent me a note. You've been here 11 years now. Have you been a front room? How long have you been front room flight controller?
I've been a front room flight controller since, oh boy, you put me on the spot there, 4 or 5 years now.
So no stranger to what happens in the front room, and of course everybody has backroom support. But talk a little bit about specifically what this EVA has in store for you guys, and there's some little nuances that we'll talk about too. But talk to me about what you guys have planned for tomorrow.
Well, for those of you who are just watching the EVA briefing video overview, you saw the animations of what we'll be doing. And the big thing about Canadarm2 is it gives the EVA crew a good stable work platform. So if they need to reach things that otherwise they couldn't easily reach, or in this case, maneuver a big piece of hardware. So we've got these two big grapple bars. They need to be moved from the payload ORU accommodation, or the POA as we call it,
Right.
taken off of there and moved to their permanent stow locations on the ISS truss. So those are big pieces of hardware. They're tough to move around. So we're going to put Luca on the end of the arm, and we'll be able to use the arm to help maneuver him while he's holding those big pieces of hardware into position.
Do you, when you have a new crew member like Luca is, of course, I assume y'all all worked together before they even launched. So when you have a new crew member, you tend to train with that person on the end of the arm for stability, just for maybe for familiarization. But once they get past that, like their second or third EVA, they may be a free floater. That's what I've seen in the past. Is that kind of how that was planned for him, or does it matter?
I don't know what decision making went into this specific EVA. Certainly, free float tasks have their own complexities,
Especially
and
because of the size of the ORU that you mentioned.
absolutely. And, moving on the arm also has its own nuances. In particular, one of the big things is the coordination and the communication between the arm operator, who will be Karen inside, and Luca on the end of the arm. They have to make sure that they've rehearsed all of their communication, all their coordination. There'll be points during the EVA where Luca will be asking Karen, okay, move me 1 meter to my left, or 2 meters forward, or backwards, or to the side. And so all of those calls and communications are what we really rehearse ahead of time, and we need to make sure our crew members are working well together on all of that.
Now, you mentioned the ORUs. You have a couple of images. I don't know if you want to talk to those now, but there's your first one.
Yes, that's right. And here you can see this is kind of just a screenshot similar to the briefing overview animations that I know you guys have been showing recently. And this is a picture of, an animated picture of Luca on the end of the arm reaching out to grab those grapple bars, and you can kind of see the grapple bars in the center of the arm. Of course, we've highlighted Luca in bright red there, so he's easy to pick out. You can see how he's perched on the end of the arm reaching out to grab these big pieces of equipment. In the next picture, you can see a shot of him holding the grapple bars in position at their permanent stow place. This is the grapple bars that are going onto the starboard truss. And of course, Chris will be free flow, as you mentioned, and coming in to help bolt those down into place. And the third shot is just a similar position of the second grapple bars being stowed over on the port side of the truss.
So this is a real good example of the choreography, if you will, between robotics and the humans, obviously the two crew members that perform the spacewalk. And you talked about the training, but how much do you have an idea of how much you guys trained, knowing this was coming, how much you trained before they actually flew?
Absolutely. Well over a year ago, we started working on the detailed procedures. Of course, as you and I'm sure your viewers know, we spend a lot of time sussing out every single little detail, and we develop for the crew line by line instructions or procedures on how to perform these operations. So we started working on those well over a year ago, and then, of course, we started training the crew. As you probably also know, our crew members spend a lot of time traveling. So, in between their various trips to Russia, Japan, Europe, we had training sessions with them here in the United States. And we taught them, first of all, generically how the arm operates, how to fly the Canadarm2, but then also the details of the specific task. And we use a lot of different facilities to do that. We did a lot of training sessions in the virtual reality laboratory together with the EVA crew members. They wear their helmets and they get to see a visualization of the space station, and with Karen at simulated arm controls, actually moving them around, and that's one of our biggest opportunities to rehearse it. We also use the neutral buoyancy laboratory, which has a mock-up of the
Right.
arm, an actual operating hydraulic arm, and we practice maneuvering the crew members around in there. So all of those things together give us a chance to rehearse both that coordination that I was talking about earlier, but also to time everything out, because we need to know down to the minute how quickly all of these tasks are going to go.
Right. You mentioned the VR lab. That's here at the Johnson Space Center in another building over in the Space Vehicle Mock-up facility. Another activity, of course, is, after they get up there, you guys aren't all together anymore in terms of face-to-face, that is. But they have a robotic simulator on board that they can basically rehearse as well, right?
That's right. We actually have a couple of different ones. One is called Robot, which actually has joystick hand controllers, just like the real Canadarm2 does, and the crew can actually practice moving around a virtual arm in a virtual environment. We also have a simulator called Doug, and Doug provides purely graphics, not an opportunity to fly a simulated arm, but an opportunity for the crew to step through or jump this arm and simulate flying it through the various positions. And so just recently, in fact last Friday, we held a session for Karen where she was scheduled for some time to go in and fly through the robotics procedure and revisit them and freshen her memory.
Right. Now, one of the things I want to mention to everyone is Laura works for the Canadian Space Agency. She has a mechanical engineering and aerospace engineering degrees, right? One of the things I'm fascinated by is I don't know if telerobotics is the right word, but typically when we have crew members on board, if there's enough crew members in terms of like U.S. members or over in the U.S. segment, I guess, that are robotically trained, you might have the two folks outside and you have a robotics person, and as we did back in shuttle, we would have a backup robotics officer that could spell the person. If it's a long EVA, they take turns, right, over or they train for different tasks or take turns. I guess for this one, the thing I'm fascinated by is Karen has no backup on board, so her backup is sitting right here next to me, and so I want you to describe, with your background, this has got to be something that's maybe like the Super Bowl for, I don't know, for robotics, is getting to operate an arm that's, circling the Earth 250 miles up.
Absolutely. That's by far my favorite part of my job is that we do have the capability to operate Canadarm2 and, of course, Dexter, which is the two-armed robot, from the ground. And for a lot of our operations, moving pieces of hardware around, swapping out various payloads, we do that completely 100% from the ground. So the crew might go to sleep one night, wake up the next morning, and the robot is in a completely different place from where they left it, which is, I'd always like to go and, tap on the window and look inside, but we're not quite at that stage. But it's a lot of fun, and you're right, it's very surreal to be able to sit here in mission control and send commands and move this enormous robot way up there on the space station.
Right. So as Karen's backup.
Now for this EVA, we won't actually be moving the arm from the ground. Obviously, when you have a crew member on the end of the arm and
Right.
the time pressures of a spacewalk going on, you want to make sure everything goes as smoothly as possible. So it will all be Karen moving the arm. Unfortunately, she won't have anyone to spell her off. But that second person performs a lot of checks. They're making sure that the cameras are set up the way you would need to monitor tight clearances or tough positions that you're getting into. They also make sure that appropriate software files are loaded for the command parameters for the arm. Additionally, when we move the arm, a lot of the time we move it using joysticks, but a lot of time we'll also type in a final position that we want the arm to maneuver to and essentially press a big go button, and the arm will maneuver to that position. And of course, as you can imagine, making sure you type in that destination position accurately is a very big deal.
Right.
And so that is the kind of thing that the backup person, what we call the M2, would do. And so we'll be performing those functions from the ground. So there'll be various points in the procedure tomorrow where Karen will be holding and waiting to get a call from myself through the Capcom to say, yes, that destination looks good, or the appropriate file is loaded, you're go to proceed. And so that's how we'll be doing that function from the ground tomorrow.
Great. So quite a bit of choreography between the ground. You may not hear it on NASA TV, but through the flight director, through Capcom up, so you'll hear a lot of interaction, not only between the EVA officer, Ernie Bell, obviously, and his team, but also with you and your team as well.
That's right.
So it's a very intricate process, and obviously robotics is a big part of what you'll see tomorrow. And Laura was kind enough to take a few minutes, as she is on duty in the room right now on this shift. So she's on until 3:30 this afternoon. So it was great of you to stop by and describe what's in store for tomorrow, and we're looking forward to seeing it all. Thanks a lot for coming by.
So am I. My pleasure.
That's Laura Lucier. She's the robotics officer here in the room on the current shift, and she'll be on duty tomorrow throughout the EVA that Chris Cassidy and Luca Parmitano will perform beginning just after 7 a.m. by the schedule on Tuesday.